All right, so I am going right to example 2. We'll do that, and then we'll do one other theorem that's pretty basic. It's not that big of a deal. So this one right here is really the one that I want to cover. It's got some algebra on here that you should have. It seems like I say this every class. You should have done this. I've said it in here before. In where? You should have done the math where before coming into here? In Algebra 1, right? But not everybody has the same Algebra 1 class. Not everybody gets, quite as far. So, I don't think I am. I haven't been told. I would love to. I love teaching Algebra 2. That's probably one of my favorite things to teach. But Mr. Rao's got it, and I definitely don't want to teach CP Algebra 2. No offense to the CP people if they're listening, which they're probably not. But there we go. That's kind of like the example in the book. Let me stretch it out just a little bit, make it look a little bit more like in the book. Yeah, that looks pretty good. Probably don't have to have it quite so big. Let's make it a little bit smaller. There we go. That's good enough. It doesn't have to be exactly like in the book. So here we go. Let's label it. So this is J. It's supposed to be a K. Let's try that again. There we go. This is M down here, and it's L right here. Now, they say that the length of this side is X, which means we really don't know what it is. The length of this side is 2y plus 1. But what do I know? If they tell you that it's a parallelogram. Okay, they say it's given that this is parallelogram JKLM. Just by saying this, what does that mean? It means this is a what? It's a parallelogram, right? Okay. And what did we learn yesterday about a parallelogram? What do we know about the lengths of the side, the opposite sides of a parallelogram? They're equal to each other. Exactly right. So we should be able to set this up. But then we're going to look at it and we're going to say, this is a little different than my normal everyday algebra. It's a little bit different. You may have done this. You probably should have done this. They give you something else too. This is 7a degrees, and this is 13a degrees. All right, that's everything they give you. So what you need to find is this. You need to find the length of all 4 sides, and you need to find the measure of all 4 angles. All right, that's what they're asking for. Everybody got that? Let's do the sides first, okay? So what did we just say? The opposite sides are what? Equal to each other. So what am I going to do? I'm going to say x equals what?
2y.
Yep, 2y plus 1. Good. All right. So what else are we going to write down? What other sides are equal? 2x, right? Yep, is equal to 5y minus 2. All right. So look at this. Could I just use this one equation right here to solve for x or y? Just that one equation by itself. I could? How would I solve for x? With just that one equation that's in the box. Now, I got one equation. How many variables do I have? Come on, talk to me. Act like you're here. I got 2 variables, right? I got an x and a y, right? Everybody sees that, don't they? Don't you? All right, so I got 2 variables, but I have one equation. Here's something that I didn't learn until I was in college. I don't know why. Really, I didn't go that high in high school in my math. My highest math class was in high school was Algebra 2. That's all I had. And then I became a math major in college. If my future self should go back in time and slap me for becoming a math major, it actually worked out fine because I like what I'm doing and that kind of thing. But I had no business being a math major after only taking Algebra 2 in high school. But nobody told me. I signed up for it, and the rest is history, I guess. But I struggled. I really did. Just because, when I was in ninth grade, I was in public school. They had a course called Algebra / Geometry. Okay. It was Algebra Geometry 1, Algebra Geometry 2, 3, and 4. What that meant was the first 2 years, 9th and 10th grade, they basically took Algebra 1 and split it in half, right? So you take half of Algebra 1 in 9th grade, the second half in 10th grade. And then, guess what? In 11th grade, you would take what? The half of No, not algebra 2, just geometry. Okay, so I was on that course. It's because I didn't do that well in like middle school math. I mean, I did okay, but they suggested that I do that instead of taking a regular Algebra 1 course. I should have definitely taken a regular Algebra 1 course. So I was on that track. When I went so I was in public school up till 10th grade. So I had Algebra Geometry 1 and 2, right? Which means I only really knew Algebra 1. When I went to a Christian school in 11th and 12th grade, and then I went right into geometry. So I took a full year of geometry in 11th grade, and then I took a full year of Algebra 2 in 12th grade. So by going to Christian school, I actually went one more math class than I would have if I would have stayed in public school. But I still only got up to Algebra 2. So anyway, long story, that's it. But when I was in college, here's my whole thing. When I was in college was the first time that I learned this. If you have two variables, you must have two equations to be able to solve for both of those variables. Do you hear me on that? All right, that's pretty important. So if I'm solving for two variables, what are my variables here? X and Y. If I have one equation with X and Y, there's no way I can just solve for X with that one equation. Is there? No, I can't subtract anything, divide anything. There's nothing I can do to this to find what X is actually equal to. I need another equation. And here's my other equation, okay? So now I have two equations with X and Y. Now I should be able to solve for X and for Y. This is the easiest way to do it. It's called substitution. Do you remember substitution? You probably did some substitution, but watch this. We kind of know what X is equal to, don't we? Not exactly, but we kind of in terms of Y. So X is equal to 2Y plus 1. Well, this X down here represents the same exact number as this X does right here. But what is X equal to? It's equal to 2Y plus 1. So guess what we're going to do? We're going to substitute what X is equal to in for where? This X right there. Did you guys do that in Algebra 1? Yeah, that's a common thing that you should have done in Algebra 1. I kind of figured you did. All right. So now, what we're going to do is we're going to rewrite this second equation, but instead of saying 2x, we're going to put what? 2 times 2y plus 1. Very good. Okay? So 2, and then if I'm multiplying it by 2y plus 1, what do I need? Parentheses. Good. So 2y plus 1. And what did that do for me? That substitution gave me one equation with what? One variable, just the y, correct? You see that? So now, what can I solve for right here? I can solve for y, all right? And that's pretty familiar. All right, let's do it kind of quick. So distribute, remember distributive property? So that's 4y plus 2 equals 5y minus 2. What am I going to do? Let's keep the y on the right-hand side because it'll keep it positive. So I'm going to subtract a 4y from here, subtract a 4y from here, and let's get rid of that minus 2. I do that by adding a 2. All right, hopefully you're following along with my algebra. 2 and 2 is what? 4. And what's 5y minus 4y? Y. So what's y equal to? It's equal to 4. But that's not what they ask. They ask to find the length of a side. So which sides can I find? Well, I could find this length right here, couldn't I? Okay, actually, I could find all 4 of them now. All right, just by knowing what y is, I could find the length of all 4 sides. You're like, well, how could I find the length of this side? That doesn't even have a y in it. But I can find this. And what's true about these two opposite sides? They're exactly the same. Okay, you with me? So let's do it. Let's do it in our head. Okay, we can do that. 5 times 4 is what? 20 minus 2 is 18. So this length is 18. What's this length without doing any math, without even solving for x? What's this? It's 18 as well, okay? Now, this is not going to be 18, but let's find out what it is. It's 2 times y. I figured out what y is, so 2 times 4 is 8, plus 1 is 9. So that's 9. What's this up here? That's 9 as well, okay? So that was a little bit different than we've done this year, but it's something that you should have done in the past, all right? But you probably haven't done it in a long time, so that's a good refresher. Is that okay with you? A little substitution. Did you also do elimination? Did you do substitution and elimination? Okay, yeah, because they kind of go together, right? Once you learn substitution, then the next thing they teach you is elimination. But on this one, that's substitution. All right, so What else do we have to find? We got our 4 sides. What else do I have to find? The 4 angles, correct? All right, so I got this. I got 7a, and I got what? 13a. So what do I do with those? Do I set them equal to each other? No. What am I doing? What are they? They're supplementary. Very good. They add up to what? 20a. Yeah, 7a plus 13a is 20a, but what do the angles themselves add up to be? 20. Or 180. I was thinking of the 7 and the 13. 180. Would you agree? Is somebody at the door? Okay. So watch. So 7a plus 13a. What are we going to do with those? I don't just write 20a. What do I set it equal to? 180 degrees. Remember these angles right here are supplementary. All right, and there we go. So let's do the math really easy. That's 20a. That's equal to 180. We divide by 20. Divide this by 20. What's that give us? A is equal to what? 9. No, not 90, because the zeros canceled out. It's just 9. So does that mean this is 9 degrees? No, it's A. So it's 7 times 9. What's 7 times 9? 63. So that's 63 degrees. Okay. Now, I could plug it in here, or I could take 63 away from what? 180. All right. And we get 117. All right. So that's only 2 of them, but really, those are the 2 that are the hardest to find. So what's this angle K going to be? 117, because remember the opposite angles on a parallelogram are equal to each other. So that's 117. And what's this angle L down here? That's 63 degrees. And we're good. We got everything. All right. We got all 4 angles. We got all 4 sides. And that's what they ask for. Is that something you think you can handle? Yeah, I think so. All right, go back and look at it. That's why I'm recording it and putting it on YouTube, right? All right, let's do one more thing, and we will be finished. This is really super easy. It's kind of intuitive. What does that mean? I say that a few times, don't I? What does that mean, to be intuitive? Anybody? You don't know what I'm saying when I say that? Where's that word come from? Into what? Intuition. All right. You ever hear that word, intuition? What does that mean? Intuition? Yeah. Money. It's what? Money? Oh, for like tuition? No. It just means, it just kind of comes natural. You kind of look at it and you're like, oh yeah, that makes sense. It just looks like it. All right. It just is something that, I don't know. We should look up the word, shouldn't we? Do we have time? It's not going to show up on YouTube, but that's okay. Intuition. Definition. There it is. The ability to understand something immediately without the need for conscious reasoning. Okay? So it's like just something that comes to you. All right? Does that make sense? All right? You're like looking at something, you're like, oh yeah. So I'll show you why it's intuitive. These 3 lines, what do you think might be true about these 3 lines right here? Right. So that, and that are parallel. These are transversals, okay? So what if I told you that that line segment was equal to this line segment? What do you think might be true? This is where the intuition comes in. What do you think? Without even like looking at it and doing any math or anything else, just off the top of your head, all right? What do you think might be true about this segment and this segment right here? If these 2 are equal to each other, that they're equal as well. Does that mean that this one's equal to this one though? No. So what am I going to do? How many dashes am I going to put? Yeah, put 2 little tick marks here and 2 little tick marks here. And that's basically what your theorem says. So if you have 3 parallel lines, all right, cut by transversals, if this little, they don't say this little segment, it says they divide every other transversal into congruent segments, all right? So if these 2 segments are congruent, then any other transversal is going to be split up or divided into equal segments as well, okay? So I could put another transversal in here, couldn't I? Let's slant it a little different, all right? So what's true about this segment right here and this segment right here? They would also be congruent to each other, equal to each other. You understand what I mean by intuitive? Yeah, it kind of makes sense. I mean, if I saw that that and that are equal to each other, you probably figured that these would be equal to each other. So what if I said that this was 5 and this was 5 and this was 3? Then what could you tell me about this segment right here? It's 3. That's as easy as that. Okay? You know they're not always going to put just numbers here. They could put, like we just did, they could put x's in there, y's in there. You might have to solve for something, all right? But that's what the theorem says. They give it a fancy name. I don't care what the name is, but they call it the congruent division of transversal theorem, right? It's kind of boring. The congruent division, and it kind of makes sense, right? Because you're dividing this congruently, all right, and of a transversal. All right, yeah, it makes sense, but I don't care that you memorize that at all. All right, well, that took us right to the end, so that's pretty good timing. So your homework is 6-2. I didn't give you homework last night, did I? All right, so there you go. So we're doing 1 through 17. Then you're going to jump to 21 and go to 24. Okay? Yeah, we'll have a quiz tomorrow. We'll go over this a little bit, okay? So we'll kind of split a little review and the quiz. All right, so be ready for that.